So let's go ahead and try example number 2. So let's pretend that these do not have the same basis because I want to practice using my natural logs. So according to this, I introduce ln's on both sides. So I have ln of 2, 5x equals ln 2, 3, negative x plus 1. All I did was introduce these natural logs. And according to my rule, I can go ahead and say that they are going to be, I can go ahead and use the exponent rule. So I get this exponents right here, all of this exponents right here, and I bring them to the front as the new coefficients. So that gives me a 5x ln of 2 is equal to all of this together, 3 negative x plus 1 ln of 2. There will be some combining of like terms here with this 3. Okay, so what we have here on the left hand side, this stays the same. It's already simplified, ln of 2. But as you can notice, this 3 needs to go ahead and distribute to both parts. So let's do that. So this gives me a 3 times an x. That negative 1 is included, so it's negative 3x plus 3. All of this remains in parentheses, ln of 2. Awesome. So let me go ahead and continue combining like terms. Well, notice this is on the outside, so you have to go ahead and distribute to both. So let's continue. This on the left hand side stays the same, 5x ln of 2 equals this right here, ln of 2, and I distribute it to the first part, which is this part, negative 3x, so it's going to be negative 3x ln of 2 plus ln of 2 times this 3. So I get 3 ln of 2. Okay, now I need to solve for x. So I notice that this has an x term, this has an x term. In order to solve for it, I need to put everything on the same side. Everything that has an x, has to move to the left. So I have 5x ln of 2 minus, this was already a minus, so it has to be addition 3x ln of 2 is equal to this ln of 2 stays here because this does not have an x. Okay, so we can go ahead and notice that this has a x and this has an x. We can go ahead and factor out the common term. And in this term, if I factor out the x, I'm left with 5 ln of 2. And in this term, if I factor out the x, I'm left with a positive 3 ln of 2 is equal to 3 ln of 2. Okay, do you see any like terms? Well, these natural logs are base 2, so I can go ahead and combine that, and that gives me x, 5 apples plus 3 apples, that is 5, 6, 7, 8 ln of 2 equals 3 ln of 2. So I go ahead and solve for x, 8 ln of 2 divided by 8 ln of 2. This gives me a solution of x equaling 3 ln of 2 divided by 8 ln of 2. We have the same term on the numerator, same term in the denominator. They equal to 1, so x is equal to 3/8. Okay, now is this the only way to solve this? Well, no. We first need to attempt that we need to go ahead and check, do these have the same base? Well, I told you guys to pretend like they did not, but in reality they did. So let me rewrite that real quick. It was 2, 5x equals 2 to the third power negative x plus 1. The only requirement is that they must have the same base. If they have the same base, I take the exponents and set them equal to each other. This will also give me the same solution. I just have to simplify. This gives me negative 3x plus 3 because I distributed. And I combine like terms. All the x's go to the same side. So I add x, I get 8x equals 3. And then I solve for x by simplifying, by dividing the multiplication, the reciprocal. So x equals 3/8, which was the same solution that I obtained by using my natural logarithms. So what I first want you to do, as you can notice, is find the same base. If you tried your best and you cannot find the same base, that must mean you have to go ahead and use your rules of logarithms. Let me see if I can zoom out a little bit. And we can notice that they were indeed the same answer, and we did two different forms. Awesome. Thank you. Bye.